Hi, I'm Cassie, and I'm going to walk you through question 14 of the AAMC Physics Question Pack. So this is a continuation of passage 3 about the Doppler effect, and specifically we're looking at the relationship between the speed of the transmitter as it's going away from the receiver and how that affects the wavelength of the signal that you're measuring. First, I like to think through the conceptual part. Our transmitter is a fancy way of saying the source of the sound, the thing that's releasing the sound or the light, the thing that's releasing the wave that we're measuring, right? We're measuring its frequency or its wavelength in this case. And then the receiver is the thing that's measuring, the wavelength in this case, the thing that's measuring the thing the source is releasing. So we're just going to call that the observer to make sure that we're clear on what's happening here. So we talked about it in the last question 13, how with the Doppler effect, you should think of an ambulance, right? When an ambulance is getting closer to you, when you're driving your car, you hear a more high-pitched sound, so frequency increases. So I'm going to say when two objects have relative motion, so whereby they're getting closer together, you're going to get an increase in frequency. And now, what's the relationship between frequency and wavelength? Well, we know they're inverse, and we know that because of what equation? We know that for the equation velocity equals frequency times wavelength. So therefore, if frequency increases, for velocity to stay the same, wavelength must decrease, okay? But in this question, they're not talking about things getting closer together, right? They're talking about things getting farther apart. So by, of course, the opposite, if our objects have relative motion between them, whereby they're getting farther apart, then we're going to have a decrease in frequency, which is going to be an increase in lambda or wavelength. Just like when we had an increase in frequency, it was a decrease in wavelength. Okay, so now which of these graphs matches that case? Well, let's take a look. I just used V to represent speed to simplify here. Basically, in case A, we have a linear relationship between the speed of the transmitter, the source of the wavelength, getting farther away, right? And the perceived wavelength that's being measured. So you can think of it as like the faster that the transmitter is moving, the farther apart it's going to get from the thing that's measuring its signal. So just like we said, what we're looking for is this case here, right? That the farther apart the objects get, then we have an increase in our wavelength. And that's exactly what this case is showing, right? As we increase V, we're also getting an increase in our wavelength here. So A is going to be the right answer. Let's think about, though, why the other answers are wrong. Well, what's going on in B here? We just have a flat line, right? So that means there's no change in wavelength, right? As our transmitter gets faster and therefore farther away. So, okay, B is out. And C, we were looking for an increase in wavelength, we said, right? We want to increase wavelength. But what's happening in C is actually we're getting a decrease in wavelength, okay? So C is out. And then what's going on with D? Again, we're getting another decrease in wavelength. This time it's just a linear decrease instead of an exponential decrease. Okay, so that's why the answer is A. So just to wrap it up, right? Always remember with the Doppler effect to think of that example of the ambulance siren. When your car is getting closer to the ambulance, you hear it as being higher pitch, so a higher frequency. And then since frequency and wavelength are inverses, if you hear a higher frequency, it means a lower wavelength. So if you're getting two objects relative motion closer together, you're going to get a decrease in the perceived wavelength, versus two objects getting farther apart, you're getting farther away from that ambulance. You perceive the frequency as being lower, and therefore the wavelength must be higher. So in this case, we were just looking for a graph that matched that case, where the farther apart the objects got, in this case the proxy being the faster they were traveling away from each other, the farther apart they're going to get, you're going to get that increase in perceived wavelength. Hope this helps. If it helps, give it a like and follow my channel for more content like this.